Hello everyone, my name is Shivam Parmar and I am going to represent a theoretical analysis of solar PV wind hybrid power system in the Kutch region. This project is carried out for the subject electrical power system supervised by Dr. Mohsin Jamil. In the table of content, first I would like to represent introduction, after that site selection and mathematical analysis for solar PV and wind power system is discussed. Then in the result section, the overall average capacity utilization factor CUF, annual average monthly yield and average daily yield are discussed. Renewable energy generation techniques have improved in the recent years and the electricity production cost with solar PV has decreased because the price of solar panel has been reduced by almost 60% in the last 10 years. India has set an ambitious goal of achieving 175 gigawatt of installed renewable capacity generation by 2022. But the fluctuating nature of solar and wind electricity challenges grid security and stability. Solar and wind resources are synergistic and hybridizing these two technologies will help in lowering fluctuation. The supreme position of wind and solar resource map indicates that there are substantial regions with high to moderate potential for both wind and solar, and the Kutch is one of the regions. It is critical to evaluate the site before installing the solar PV system because even the best solar panel with maximum performance will not generate maximum output if the area has insufficient photovoltaic conditions. The solar potential of a location affects the energy production of a photovoltaic system, and the climatic conditions for solar and wind energy will be discussed in this section. In the Kutch region, the temperature ranges from 11 degrees Celsius to 38 degrees Celsius throughout the year. Temperature reaches its peak in May with an average peak temperature of 38 degrees Celsius. The figure shows the daily direct shortwave solar energy hitting the ground surface. Shortwave radiation is made up of visible light and ultraviolet radiation. Over the year, the average daily incident shortwave solar radiation varies seasonally. The lighter season lasts 4 months from March to June, with an average daily incident shortwave energy per square meter of 6.9 kilowatt hour. Direct shortwave solar energy is maximum in May, with an average of 7.4 kilowatt hour, and its minimum in the December, with an average of 4.7 kilowatt hour. The below figure shows the average mean hourly wind speeds in the Kutch region. As we can see in the figure, the windier season lasts 6 months from April to September, with an average wind speeds of higher than 17.7 km per hour. July 1st is the windiest day of the year with an hourly wind speed of 25 km per hour, and November 5th has the minimal wind speed of 10.6 km per hour. In this section, mathematical analysis of solar PV system is discussed. The total energy generated by solar PV system can be calculated using equation number 5, where AT is total solar panel area, N is the solar panel efficiency, HGA is annual average solar radiation on tilted panel, and PR is performance ratio, which ranges between 0.5 and 0.9. We have taken 0.7 for this system. For the wind power system, the mechanical power of wind turbines can be calculated using equation number 6, where Cp is power or bench coefficient, which value is 0.593. V is wind speed, rho is density, and A is swept area of rotor. Table 1 shows the monthly energy generation based on the parameters used in calculating system performance based on the above mathematical analysis section. Table 1 indicates that total energy has a significant impact on increasing both solar radiation and wind speed. By combining solar and wind energy, we can generate between 200 to 500 kilowatt hour of energy every month. From March to August, The energy generation is between 300 and 500 kilowatt hour due to significant solar radiation and good wind speed in the monsoon. And the total annual solar PV wind hybrid generation was 3768 kilowatt hour. The figure on the left depicts daily solar PV energy, wind energy, solar PV wind hybrid total energy and average energy. Solar PV energy ranges from 2.1 to 5.2 kilowatt hour, while wind energy ranges from 3 to 12.1 kilowatt hour. And total solar and wind hybrid energy ranges from 8 to 16.9 kilowatt hour. As we can see, wind energy generation is twice that of solar PV energy from April to June. The figure on the right shows monthly solar PV energy, solar PV wind hybrid total energy and the average energy. As we can see, the monthly solar energy output ranges between 5.56 and 155 kilowatt hour, while monthly wind energy production is between 82 and 362 kilowatt hour. From the total annual 3770 kilowatt hour solar PV wind energy generation, around 2300 kilowatt of hour energy was generated between March to August, which is about 62% of the total energy generated. And from September to February, solar PV monthly generation is 30% to 60% higher than monthly wind generation. The below figure shows the capacity utilization factor CUF of energy generation of solar PV wind, solar PV wind hybrid energy and average energy. As we can see, from October to February, solar energy CUF was higher than wind energy generation CUF. Similarly, from April to August, wind energy generation CUF was higher than solar energy generation CUF. While in March and September, both CUFs were almost equal. The figure shows that the theoretically calculated value of monthly solar CUF varies between 8% to 21%, and the monthly wind energy CUF varies from 12% to 49%. Due to higher radiation and more wind speed, solar PV wind hybrid power system energy production is expected more in summer and rainy season, that is from March to August. During this period, the CUF of solar PV wind hybrid power systems varies from a minimum of 41% to a maximum of 70%. Results showed that a 1 kilowatt solar PV and wind hybrid power system can produce between 7 and 17 kilowatt hour per day. The overall capacity utilization factor is 21%. The annual average monthly yield is 157 kilowatt hour per kilowatt per month, and the average daily yield is 5 kilowatt hour per kilowatt per day. Using a solar PV wind hybrid power system, we can estimate energy output between 30% and 70%, which can be used in the state with minor modification to the current infrastructure. As a result, infrastructure cost may be reduced and the wasteland between the wind turbines can be used.